Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. Go to soten.z.dev if you want to know more about the Castlevania Symphony of the Night decompilation project. I am a contributor to this project. It's not my project, I just like working on it. At soten.z.dev you'll see a bunch of the progress that we've made on various overlays. We've been working on the Sword Familiar overlay, and we're going to keep doing that today. There's only 5 functions left, and between what I've been working on offline and the help that we've gotten on the stream here, we're well on our way to getting through this. The remaining functions do have some challenge left in them, and we'll take a look at what some of those challenges are today. Some of them are tooling issues. There's a lot of tools used in the decomp community that aren't PlayStation specific, but maybe could use a little more knowledge of PlayStation specific instructions and architecture. But we can get around that. And fortunately for Castlevania, we have multiple versions of the game that we can look at that don't necessarily have the same limitations. As I always say, at soten.z.dev you can find a link to the GitHub repo where all of the code that we've decompiled can be found. And you can also find a link to the Discord server where you can learn more about the project or join us and decompile yourself. Howdy, Anti-Gravity Well. Good to have you back. I spent some time on my 3D printer over the weekend. I thought you might be interested in that. I have I couldn't remember which one I had. I have a Ender 3 Pro, and I was looking at the board that I have. There's a silent motor board. I'm not sure if I should upgrade to that. There's also a Big Tree third-party board, and I think I'm fine for now. My issue I learned over the weekend, I believe, is that I melted my PTFE tube, and my filament is sticking there, and so I have to decide if I should upgrade to a heat break. I ordered some new tubing, and hopefully can get back up sometime this week or this weekend. I want to my the print that I got stuck on a few months ago and haven't been able to get past is just some hex pieces for laying out a Settlers of Catan game, because we have one of the modern versions of Settlers of Catan that has the terrible border where all the pieces don't fit quite right, especially if you don't have a perfectly flat surface. Yeah, buying a new one isn't in my future, but the other issue that I have, and this is my own idiosyncrasies. The best color to print is glow in the dark, and if you've printed glow in the dark filament before, it has oh no, I can't. Of course, I can't remember the element, but it's a coarse element that is harder than brass, the brass nozzles. And so I use hardened steel nozzles, so my temperature is usually up around 220, 230, and that just makes everything more complicated, even though I'm just printing PLA. Yeah, bad. Yeah, and I've looked at getting like one of the manufactured ruby or sapphire ends with a brass nozzle. I don't know if that helps at all keep the temperatures down. Hardened steel is not that bad. If I can get the higher temps, I think I'll be fine. Yeah, I spent a lot of time Z-leveling. And I have considered adding an auto leveler, but let's get back to Castlevania and see where we are. So looking at what we have left, there's 5 left. 2 of them haven't been looked at all. The remaining 3 are in various states of decomp. I want to review those quickly and just show where things are. I've been working on E84 over the weekend, and that one has the tooling issues that I was mentioning earlier. Let me look at the last one, F28, is the smallest of the remaining ones. There, we worked on that quite a bit on the stream, and it had some issues with this loop down below and why some of the addressing in these arrays was being funny. Haven't figured that out yet. And then B6C is the main driver function. It looks like Eugene, who has contributed recently, has worked on that as well, and got much further than I had gotten. This is, I believe, the main state machine, and it might be interesting later in the week to go look at that. And then B6C, that's what we were just looking at. And this is the PSP version. So the one I want to talk about briefly is E84. So E84, if we look at M2C's decomp, we just get a very broken, full of M2C errors. And I haven't gone back. I've mentioned before, every time that I look at M2C and feel like, oh, it's going to be a simple change, I just haven't been able to understand what the structure of their project is. It's in Python as well, and I'm not a Pythonista by any stretch of the imagination. So we actually have to do a lot of relatively manual work here. And these aren't terribly difficult. All of these actually came as macros in the PS1 SDK. And so we can look at the header from the PS1 SDK and find what a lot of these are. And Sozu and others have already imported all of that into the repo for the most part. There's actually one that I found in here today. Maybe it was yesterday. No, I don't see it at the moment. But there was one macro that hadn't been imported yet. And looks like it was the first time that it was used in this function. So we're finding stuff that hasn't been touched yet in the PS1 SDK. And so when we're going through this, we don't have M2C to base our code on. We either have to know what these macros are, or use other techniques. But it's a very manual and slow process. I hadn't, up until this point, pulled in the PSP version. I did that just before the stream. And the PSP version, if we look at that decomp, is actually much nicer, and that's because because this was recompiled with M2 or with MetroWorks from the source. A lot of these functions that were inline macros are actual functions on the PSP because it's targeting the PSP hardware and not the PlayStation backwards compatibility. So we get the benefits of having a really nice decompilation and can leverage that. And I think we'll spend some time on that today and looking at what we can learn from that. So this function, when we see a lot of these GTE macros, these are the geometry transform engine, which was a custom coprocessor for the PlayStation. This was added in place of a math coprocessor that might have been in a lot of MIPS chips, but was specific for the system. I do think this isn't generic MIPS. It is PlayStation specific, but a lot of these patterns are just well known because they came from the SDK. And so adding support to M2C for this kind of stuff probably makes a lot of sense because it's going to happen in the majority of PlayStation projects. So I might spend some time looking at that. We'll see. So I'm not going to start with the assembly. I am going to just go with what we have here, and I'm going to go over to what is on the PSP side, and I'm going to start merging what the PSP decomp provided with what I've already done for the PlayStation and see how far we can get. There's a bunch of things here, macros that I probably will need to fix. These are using the scratch pad and offsets in the scratch pad. There's a lot of that here, which also is not very friendly for M2C. But primarily what I want to find is these this set of function calls. Can we map all of those to the existing macros that we have, and then get those back over? So I'm going to do a few things to start, just for project maintenance purposes, like getting rid of this and renaming it to a variable that we have already. Actually, I do need to get this compiling first, because there is some issues. That should be resolved. So I created a new macro, and I'll go over this quickly. So we have a SP macro, and actually I noticed this spad macro uses SP, I think, incorrectly. I'll have to go back and look here. So SP is a macro that's used for the scratch pad. It may have been a different macro at some point. SPAD meaning static pad, SP, I'm not sure what that is related to. But this is going to call the SP macro and basically create a scratch pad address, and that's not what is intended there. So either this macro is broken or hopefully it's not used. Parentheses. So here's what our SP macro looks like. Basically taking the scratch pad base address and then adding whatever offset you wanted. I added a new macro called var sp, which takes a type and then just casts the SP scratch pad address to that type. It gives you something nice like this that almost looks like, I mean, it's pretty far from a declaration, but it looks like somewhat. I have a sign 32, it's at offset 14, and I want to assign it there. And the assignment then is a sign 32 assignment. And we can do all kinds of things with that then, like up here where we're getting a primitive, we can tell it the type and get type safe assignments and things like that. That has worked out pretty well. Let's see. So I was looking at what was going wrong here. And so I just need to continue that work. I hadn't tested that macro for the PSP yet. This is somewhat interesting. So this is this might not be right. I think I maybe copy pasted this incorrectly. Offset 0 for the scratch pad is just assign 32. Why this got decompiled with nothing in the condition, I'm not sure. But basically, I just need to get all of those fixed. Yeah, and as far as I can tell, this is always being used as assign 32. So I'm not sure what happened to get that cast as a primitive. What I have noticed on other overlays, and is likely worth doing, is a struct has been built out so that you can just pull the base scratch pad address of 0 and then use the struct to compute the offsets. And that seems like a pretty valuable way to do things. Okay, so let's continue on 294. Looks like RA2 is mistyped because of that other mistyping. We're seeing a error on 319. So somewhere along the way, let me make sure I didn't do it here. Somewhere along the way, we lost a parentheses. Looks like that was my fault. So I'm going to redo some of that work. No, so that was unrelated. Let's figure out where that is. Just making sure all my parentheses match. My brackets, sorry. So there's something in here that's not matching. And it looks to be here. So this condition is correct. And it almost seems like this line. Yeah, so something's happening here with the macro. And this is possibly a case where that macro isn't working as expected on. MetroWorks, or I just broke it in some other way. I'm not sure what is going on, why it doesn't like that line. Okay, so this is matching now. that's fine. The next one, so this this should be of RSP as well. It might help to take this back to GCC and just make sure that everything's working fine there as well. So a bunch of these got mistyped. Still have an error. I'm going to pull this back and see if that error persists. It doesn't. So there's something not quite right. I'm going to bisect as much as I can and try to figure out where this may be failing. Oh, I missed this. So I was assuming that this was a error about the sorry, the bracket, but it's actually a completely different error. And that's because many of these GTE methods, and I should go back through and find all these GTE macros, these are going to be function calls. And so I may have to generate a context that is specific for the PSP for these to get the correct function signatures. I'm going to try to just get rid of them and use the default signatures for those. And if that works, great. Otherwise, we can regenerate them. There we go. All right, so pretty low match so far. That's fine. It's actually very similar to what's in the PlayStation. What I'd like to do is find places where I'm missing instructions like here and look at the decomp and try to pull as many of those as possible from M2C. And as those patterns emerge, then we can hopefully fill in a lot of this very quickly. So what we have to do is look at something like draw mode. That will tell us that 7C is the same as get LDVO. And so we can look to see if there's any of these LDVOs that we don't have yet. I'm pretty sure that I have them all, so I'm not going to focus on that. ABC is our RTPS. 430 is STXY. And then we have two 4C functions, which are missing, and that is this CFC2 instruction, which we haven't imported previously. I did pull that in, so let's look at that header. So in our include directory, there's the PSX SDK. This is all part of libgte. And what I want to do is find, I didn't pull that one in yet, find the one with the CFC macro. Let me find that folder. It looks like I don't have that in a folder. Looking at the CFC2 functions, I'm going to go back here. Let's go back to the PlayStation side. The CFC2 instruction, which was originally here on line 115, we have to look at what the assembly looked like and try to match that. So it's actually probably this SWC2 that is the repeated function. And then, so we can see which function that was. That's this get STSXY, but that takes 0 arguments. I'm not convinced about that. And then CFC2, we have the CFC2 instruction, a no-op, and then store word, and then loading another address, which is part of the scratchpad. So what I really want is CFC2 followed by a no-op or load up or immediate or CFC2. I'm going to open that up. So use your legitimately obtained copy of the PlayStation 1 SDK to follow along here. So this looks actually pretty familiar, the set flag macro. We don't have this imported yet. So this one does, however, take a register. Let's look again here at the PSP side. We have 2 function calls. So I may actually be off by 1 here. It may be this B4 that should be getting that OC offset. So let's see if we can do something about that. We can actually go to the PSP compilation as well. Maybe I'll do this offline. Hey, roaming, good to have you. So we're looking at a lot of the custom coprocessor macros to catch everybody up online. I need a timer up in the corner, and every 15 minutes do like a station identification to remind people who come in what we're doing. But this 4B8 function, we don't get a lot of assistance from M2C because we're using a lot of custom instructions from the geometry transform engine coprocessor, which isn't a common MIPS coprocessor. It's so uncommon that it's only found in the PlayStation and the PSP hardware. On the PSP side, since we've recompiled, we're not using any of that hardware, at least not directly. So what we have to do is look at several of the macros and find the ones with assembly that is going to give us the right instructions, or the instructions that we're looking for. And it looks like the CFC2 no-op to a store word. That looks most like what we want. I can't remember if 12 is going to be temp. Temp 4 or not, or if that's going to come from this this variable. Let's see. Let's grab that macro and we'll add it to this context. Well, we don't have it, obviously. We'll just put it by some of the other GTE macros. And clean up my copy mess. All right, so now we have the set flag, and we should be able to use it here. It looks like this 08 is what we're going to be passing in. So we can use stack pointer 8. And we have a parse error. Let's see what is going on. Let's see if there's something missing. All right, looks like maybe just a key press that was missing. So there is this second call here, SWC. That is missing. This one actually looks like it doesn't take a it does take an argument. It's this this 08 argument again. So let's see what happens if we pass that in. If that will give us what. On the PSP side, these take no arguments. Yeah, so the load happens here, but it's not happening again. Both of these should be marked as volatile, but because these are pointers, I don't know that that there's any reason GCC wouldn't cache these. I'm going to save this, and then what I've been doing is getting rid of these as I've been going through. I'm going to go back over to the. Yeah, it is possible. It is possible, yeah, that these are a different macro, and we can see if that's come up before. Oh, wrong tab. Yeah, I don't see these as The other thing, since I'm in here, I guess I'll do this now. I'm going to build the PSP version. And then we'll have a bunch of those symbols to reference. And I think most of these GTE macros should have been assigned usable symbols at some point. And that'll make that PSP side decomp a little easier. I'll let that run, and we can come back over here. Yeah, you're probably right that this is has been done before. If we look at what is over here, though, these symbols, they're not prefixed. Normally, for all of the new PSP stuff, it's going to have PSP in the prefix. So these symbols have come from something that was imported before. That has run much quicker build than I thought it was going to be. So what I'm going to do is look in the PSP EU build directory, just look at all the maps and see, not amps, maps. See if that address had been used. These are case insensitive. I don't see it. Let's look at the symbols as well for PSP EU. No. That's a bummer. Yeah, so there are functions around that area, and they're going to be functions that are probably in DRA that have had just the automatic mapping. Yeah. So we can come back and maybe make macros for those. It is kind of, so when we're thinking about the scratch pad and how that works, having a macro that assigns a global, it's probably not, like, from a modern programmer sensibility, that's not something that you would probably do, but this obviously was written in a very different time and very different tooling. Hey, Nate the Great, good to have you back. Always enjoy everybody who shows up in chat, and really appreciate all the people who come back day after day to watch me struggle. I shouldn't say struggle. This actually is. Today is going to be one of the harder ones. Harder in that just a lot of manual work. I really do appreciate everybody showing up. All right, so we have a lot of the same or similar offsets into the PSP scratch pad. So that tells us we're going a good direction. Let's do this. Let's make a macro for that. Maybe that macro. Maybe that macro will be wrapped in a do while. Let's look at that and see if that helps at all. So if we call set flag twice, no, we need STS XY. Yeah, we are loading two different things here. I'm not sure why that would be the same function, because our instructions on the PSP side are different. This actually might be worth looking at those PSP functions, if I can find them. For now, let's do this. Let's see if a do while is going to allow us to reload this address. This would be a relatively common pattern. For for a macro like this anyway. No, it doesn't reload. So this is going into a temporary register. Does that help us at all? Let's go back here on the PSP side. I want to look at the instructions. So we get these as function calls, which is nice. It is possible that the no, I don't think MetroWorks would do this. I was going to say it's possible that the argument is already an A0, and so it looks like it's a no argument function, but yeah, that's possible. I can't imagine MetroWorks doing that because it is so explicit. Let's try it. So here we're loading the A0, and then we're loading A0 again. Yeah, so it's going to be I would imagine so. Yeah. So I don't think it can trust what's in the A0 register. I don't think it's restored. The other thing here is it's possible that I want to get back to this quickly on the PlayStation side. So we're doing this set flag macro, and that matches up well. And we have this. Yeah, we are at offset 8. What I will do is, this is a pointer to, I believe, a 32-bit. I'm going to try something a little different. I'm going to make a pointer to that. Make it volatile to force the assignment. And then pass that that pointer in. That doesn't jive with the T variables being, or the T registers being used, but I'll give it a shot and see if that works. It doesn't. That's surprising to me. So we do get the assignment here if it's different, but not otherwise. So there's something happening here that it is possible, I guess, and I didn't consider this, that that this is written as inline assembly directly, and that these are not actually being pulled in from variables. I'm not sure. We'll come back to this. Too much time spent here. So then there's an MFC2 call. Looking again back at, I'm going to take this over the way that it is, and we'll be a little off, but the structure's getting there. We'll figure out going on a little bit. So we're restoring or moving off the return value. I don't know if that makes a difference yet. That register isn't being used. We'll see about that as well. What I'm mostly concerned about at the moment is just getting the general structure right. So here, here's a load word. We're loading this primitive offset 10. So here, the immediate differences are because the scratch pad offsets are different, and I don't have the right macros right now for the PSP. Maybe I should pull that in just to get rid of that noise. All right, so we're loading this primitive pointer from the scratch pad. Then down here, we're doing it again. Sorry, right after RTPS. Why? I'm not sure, but the PSP is. I was gonna say maybe this is why that address is being reloaded, but no, I don't think so. I don't think that this is even going to affect the PlayStation at all. So I just pulled that back over to the PlayStation. I want to find where that is. Yeah, that instruction's not going to show up. This is just loading an address into this register, and the address didn't change, and then nothing could change that address for that register, so it's not an issue. All right, so continuing on. So this MFC2, we have as this ABC function, and we've seen ABC before. Going to decomp on ABS, ABC. ABC is get RTPS. Or GTE, sorry, GTE RTPS. That macro on the PSP side, if we look at it, it's kind of a funny macro, and it might be worth actually adding some documentation here for searchability. Effectively, this is saying GCC is not going to know what this is, so just write this, write this binary in place of this instruction, and worry about the processor figuring out what it is. That is kind of funny. Let's look at just quickly if that is what that is what the PS1 SDK did. So they shipped a version of GCC it's possible that they didn't have, like, the compiler team and the SDK team weren't in sync enough to be able to do those things. We have comments in our own code base that our RTPS and all these other functions for the for SOTN don't match what was in the SDK. So if Konami knew something, or maybe this was a patch from a different version of the SDK that I'm not referencing, I don't know. Hey, Ericum, good to have you back. All right, so anytime over here that we see that ABC function, or MFC2, that is a get RTPS. And those are easy then to find. What does get RTPS stand for? Good question. I don't know offhand. After I finish all these, I will go to the manual. See if I can find it. So this is much slower going, obviously, than when we have instructions that M2C knows about, and we're just worrying about ordering and logic and some of the typical mistakes that M2C makes. But this is more along the lines of what decompiling looked like prior to having nice tooling. Thank you. Appreciate you, chat. All I was doing here, nothing too exciting. So what I did when I imported this, to kind of back up and give some context to anybody who might just be joining, typically we have a very nice decomp from M2C, and we're worried about untangling maybe go-tos that the optimizer wrote in a funny way, types that the decompiler couldn't necessarily figure out. In this case, we're dealing with handwritten instructions that Sony shipped in their SDK that that M2C doesn't necessarily know about. And I said earlier, actually, that it would be nice if M2C handled these. It's actually possible that M2C does handle these, but SOTN uses a variation of these instructions that doesn't match what was in the SDK. And thinking about that a little further, I wonder if they use this actually as maybe a copy protection or copyright style of protection. The way that these instructions are set up, they only set the opcode, and then the rest is zeros. And so if Konami knows that that is how it works, and by this time they would have had a lot of experience on the PlayStation, they might have thrown garbage in there basically to see if anybody was copying any of their tooling. That's a theory that I would be interested in knowing if anybody else kind of went down those paths. So it's possible that M2C actually does know what these things are, but it doesn't recognize them because of this extra garbage in these instructions. So we get a bunch of errors. Now we have to go through and actually do the work of decompiling these. And most of these are macros that were provided by the PS1 SDK, and not actual functions. But then when we look at them on the PSP, Konami, for this and the later mobile releases, and since mobile also Requiem, they basically re-implemented like a portability layer for the SDK. And so they might have done that as early as the PSP to get some of these in place so that they could compile with the PSP toolchain, but use all these existing PS1 SDK functions. All right, so what does that tell us? Actually, some of these were not, like this last one, going backwards, was not a get RTPS, and so I may have pre-optimized. This is a slightly different function, and so this may be this may be something else altogether. So let's take that over and see what that looks like on the PlayStation. Still very far from a match here. So yeah, there is a different MFC2 macro that we're going to need to find. Unfortunately, it does take the same scratchpad offset. So the way that I found these to begin with is just by searching for these instructions, and so we want to find some match, and so what we're looking for is MFC2, a no-op, a shift-right arithmetic, and then a store word. So this get size OTZ, sorry, set size OTZ looks like a likely culprit, and we do have that. Oops. And we're going to be passing in the scratchpad offset C. And that looks much better. So there's probably some of these that I need to go fix now because I did the wrong thing. But we should be able to get most of those fixed up. So what I did when I was importing these, just to get something, a baseline for compiling, I just comment out everything that that isn't matching. And then I'm going through basically line by line and trying to match these macros where possible. It could go a little faster, I suppose, if I wrote some scripts to find these, but I'm not gonna do that right now. I did say I would look at what get RTPS is, and it's probably a good time to do that. So let me open the docs and see if I can find get. Or sorry, I always say get. It's the GTE prefix. If you have found like libref.pdf or any of the other PS1 SDK docs on archive.org or some of the other places, you should be able to find most of these. These GTE macros, a simple search is not coming up with anything right now. So GTE is the standard graphics library, isn't it? Sorry, basic geometry library. Yeah. These macros are not listed in libref. So let's see. Let's see if I have. Another document. I don't offhand see anything for. I see a reference here. In the changelog for GTE RTPS, but I'm not seeing. There's no documentation in the header. Actually, I am seeing. Oh, this is interesting. There are macros that combine several of these GTE instructions, and those are probably the ones that are documented. So we're going to have to do another pass of this after getting these out and see what these might be. So let's go over here. Oh, I don't have this up. Sorry. For whatever reason, Terminal doesn't Terminal does not share all tabs. I don't know why. So what I'm looking for is a macro that is GTE LDVO followed by RTPS and then STSXY, and then set flag. I'm seeing one, but then LDVO again. So that's probably not it. Excuse me while I just skim through these. Set DP. So there's a rotation translate perspective. I'm not sure if any of those are quite exact matches. I'll revisit that later. If they are, then a lot of this gets simplified quite a bit. Getting back to where we were on 123 here. Actually, I was going from the bottom to the top, just checking all these RTPS calls and seeing if this other macro needs to be used in their place. When there's a lot of missing instructions, that can become quite a bit more difficult to tell. Yeah, this is the, Orcam says, is this the Konami code I've heard about? Slightly different Konami code, but not terribly different. So this get RTPS is incorrect. We'll have to come back and see what, or we just don't have a good enough match at this point to see. Yeah, these are much slower going for sure. And so let's take this over. Now we have a bunch more. See if that changes. Oh wow. So again, all the identifiers are going to be wrong or different on the PSP, but structurally we're getting closer. That gave us another 4%, which is nice to see. All right, so let's do PlayStation again, and I'm going to work down and find these LWC2 macros. Looking at the PSP side, save. Looking at the decompilation there, what I would like to see is what these look like. So we're going to find somewhere. There we go. So we have this X0, two function calls, this passing in this OC stack pointer. Here we have get RTPS, but not on the PlayStation side. These are reversed, or on the PSP side, sorry. These are reversed. And then we have a function call where we're passing oh no, this get RTPS isn't here. So there may be something else that is missing here. Let me check get LDV0. It's possible that I had already accounted for those. Get GTE LDV0, of course. Oh yeah, that's providing the LWC2. I just didn't get rid of those. All right, going back to the PlayStation side. And what I'm expecting is basically down to X1. Sorry. Yes. This LDV0 RTPS grabbing the primitive X0 STS XY set flag, that this is a block that is going to be repeated. That's my expectation. Whether that's true or not, I don't know. We'll find out in a second. So let's find those lines on the side here. So we have until here. So here's our RTPS 0. So we have a load word. For a 0 that is missing. Yes, thank you. Thank you, roaming. Check my screens, check my screens. A0 has not been set for quite a while. Here we have the address for B54. Offset Z. Oh, this is just our primitive. So we're setting the primitive again. And we should see that on the PSP side. So we just keep grabbing this primitive over and over out of the scratch pad. It's possible that these GTE macros are manipulating the scratch pad in some way that we need to grab another primitive. I don't know. So what we should see though is this same pattern then going down. Again, Y. We see the same thing here, where same address being referenced, but we're not loading it again. And then as well here, where these are in a different order than I had them originally. So we're going to continue on, do that pattern 2 more times. Every time incrementing X along the way. And making sure that we get the right global. So this. And go all the way down to here. So still a few issues, like I said, with the loads not happening, but most of that structure is there. Let's go back over to the PSP side. And what I'm hoping for on the PSP side is kind of the same thing. Just is the general structure okay? Is there something else that is missing? Kind of as Roaming pointed out earlier, is this a macro? Yeah, definitely possible that these are a macro. We're seeing the same function call twice on the PSP side. What does that mean? Is that a change? Or something else? I don't know. This does seem like the general structure. Whether these are the correct macros or something else, I don't know. We are taking, like on this ABC, it does look like we're taking return value and moving it into arg0. ABC is our RTPS call, though. Yes, I completely agree with you, Roaming. That it might be an empty arg function looking macro. I got what you're saying. Let's go down here, and this will get us into some of the logic, which I think will should go a little more straight, or should be a little more straightforward than a lot of these other macros, and go a little better. So here we have a variable s2. That tells us it is a variable, most likely. And we're just going to do the assignment once at the end. So let's make a new variable. We don't know what this is. We'll just call it s2 because that's the register that's being used, and we can follow it later when we come back to it. And we're going to assign that to s2. And I'd expect this to compile to the same thing. So let's do this. So we're taking here this gives us a hint for the type. We're doing a load word on offset 20 on the stack. Our stack is actually pretty good, all things considered, for the PSP. This is the argument that's coming into the function. On the PSP side, our stack pointer offset was 30 or 48 bytes, hex 30, 48 bytes. I don't necessarily think we could try a ternary and see how that changes things. The S variable or the S register being used suggests that it is going into a variable first, and so it's either going into S2 or it's going into this S variable regardless, and then being assigned down here. It is interesting that that MetroWorks decided to pick v1 instead of an S variable, but S usually indicates that it is a variable. And so then similar structure here. This is using S1. Do these need to be separate variables? If these are X and Y, maybe it makes sense, and maybe this is Z. That's probably not a bad guess. Yeah, the S variables typically are stack variables. So let's do that. Let's make these X, Y, and Z, and we can come back if those aren't. It could be RGB just as well. My guess is that these are all going to be the same type of condition. So I will write those all the same way. Oh, what did I do? Broke something somewhere. Looks like these types may be incorrect. Going back up, I'm going to write this as drat. So there's a few things that we can try. What's happening is that unknown 80, which is, I called it unknown 80 because it's taking the unknown 80 field from the sword familiar extension. That's being passed in as an argument, and at this point in our version of the function, that argument hasn't been pushed to a register or to the stack, and it's sitting in S0 from whenever it was last used, and on the target assembly, this has been pushed to the stack and is being reloaded. And so if we don't do a sign extension, we're going to have a missing instruction there, but the sign extension isn't the instruction that we want anyway. We want the load instruction. And this, I can try making this a 32 and see if that changes anything. I can't remember why. It must be the type of this field made me think that it was a 16. Let's look at the decomp one more time and see what. I'm going to get rid of this. Oh, it doesn't matter because the function name is different anyway. So it looks like it is a 32-bit arg. I would trust the PSP assembly. I will tell it that this is an entity and see if I can figure out anything more from that. So that's not going to help at all with matching those loads, but I would, like I said, I would trust that the PSP type information is more accurate than the GCC PS1 type information. So except for the load words, those instructions look correct. What's happening here is I have these typed as arrays. They must be at the top. That may be from other code. I can't remember offhand if these were defined elsewhere or not, but the way that they're being accessed is not as arrays here. So I'm going to treat them as that, and then when it comes time to integrate that, I'll have to see if these are being used elsewhere and if the addressing is different. All right, so somewhere it looks like I'm still calling this a so the things that are in here in the context already are probably things that have been used already. Oops, I don't know what that is. Sorry. But this addressing matches. Actually, this addressing doesn't. So these were arrays or possibly structs. So I'll have to go back and fix those. Move those back. Maybe structs. I'll leave them as arrays for now and come back. So let's go back down here, setting scratchpad, setting this to 0. So now we have a branch here, and in the, let's go look at the PlayStation version. I'm gonna copy this over, and hopefully what breaks is minimal. It's like just this type. I need to fix the type declaration for the function. What it looked like on the PSP version was that this condition was being pulled from the scratch pad, but we're getting it from just a global. And I don't see anything referencing anything in the scratch pad at this point. Oh, there is actually this down here. Let's see. We're looking at 0 from the scratch pad, which is a just a 32 that's often used as a counter, it looks like. So I think this is where I'll end it today. So this this function coming through, and the reason that it's going a little slower and a little longer than a lot of the functions, this is using a lot of instructions that don't match the PlayStation 1 SDK, and M2C doesn't recognize them. And so when we get a base decomp, this is the PSP version, when we get a base decomp, we just get a bunch of errors. And so now it's our job to go through and figure out what those errors are. And likewise on the PSP side, we're missing a lot of symbols that may aid in helping us identify what the macros are for that inline assembly that would come from the project. So there's a little bit of work that can't be automated for us. So it takes a little longer, and it's basically fix and check, and provides a little bit more challenge than what we've seen on a lot of the stuff that we've done on the stream so far. I think it's a nice variety, though, of something that I haven't done on stream before, and what I think is really impressive is not work that I've done, but the work that others have done before me. And I'll show you some of that, which I think is just awesome that that Sozu and others, Biz Murphy, Dynamo, have done. So this comment says that all these are not part of the official SDK. They're identified by looking at the function. So somebody came in, looked at the functions. I'm going to look at RTPS real fast. So in the PS1 SDK, this starts with a 7F. So not even the first 6 bits are matching. But yeah, a lot of smart people came through before me and provided the foundation that we can work on to keep going on the stream. So I really appreciate all the hard work that everybody on this project has done, and allows somebody who's just a contributor who hasn't done a significant amount of reverse engineering or decomp to come through and be successful here. If you are interested in decompiling Castlevania Symphony of the Night, PlayStation 1, join us in Discord. You can find that at soten.z.dev. That's ZXEE. Is that the correct pronunciation? Dynamo has never corrected me, so I'm going to keep saying it. I really appreciate everybody who joins me every day in the stream. Roaming, Orcam, Entropy, Gravity Well, Nate the Great. Thank you all for showing up. And everybody who pops in periodically, everybody who is doing PRs and really pushing this project forward. I'm here Monday through Thursday. If you're on Twitch, follow. If you have a Prime sub that you're not using, hey, give a Prime sub. I'm working on trying to have appropriate access to some of the other versions of the game that I may or may not have copies of, and that's what any of the subs or anything like that are going to. Any of the I didn't think that I'd turn on ads, but if you're seeing ads in Twitch, let me know. Any of the stuff that comes from the stream, though, is going to go back into the Symphony of the Night project. So go to soten.z.dev, come back Monday through Thursday, 11 a.m. PST. I'll try to keep it on PST for consistency, and I'll see you all tomorrow. Adios. Appreciate the help, Entropy Gravity Well. I'll reach out.